As we celebrated CII's 40th anniversary last year, we are reminded of the incredible amount of valuable collaboration between academia and industry that has taken place at CII through the years. Our next presenter has been a key contributor in this collaboration for many of these years of success. He was also on my first research team, RT302, Interface Management, my introduction to CII back in 2010 timeframe. Dr. Carl Haas was our academic on that team, so we've known each other for quite some time now. Anyways, here to further highlight that remarkable history, exciting future, please welcome Dr. Carl Haas, Professor and University Research Chair at the University of Waterloo in Ontario, Canada.
Thanks, Paul. Thank you, Paul. That photograph is funny. I've aged. Yeah. I really should get that off the internet. But anyways, so good morning, and I appreciate that you're here, hanging in there between me and lunch. I'm really honored to be here today to share with you some of the things that I've learned over the last 35 years working with CII as an academic. CII has sustained a productive relationship, partnership for more than 4 decades between academia and industry. And today I'd like to talk about how that partnership began, the fruits of its success, and how it's thrived for over 40 years. And then I'll also share some thoughts on the biggest problems that we can work on together through CII going forward, and then how we can implement solutions to those problems. So when did it all start and why? There's people here who probably haven't heard the stories. If any of you were around in the early 70s, you might remember things like the oil embargo and the long lines at the gas station. You might also remember inflation reaching double digits year after year, and substantial labor unrest in the construction industry in the late 70s. So a group of the CEOs from the 100 largest companies in the US formed up around then as the Business Roundtable, and it's still around today. One of their initiatives was a series of construction industry cost effectiveness studies. They were called the SICE studies, to address cost escalation. Key leaders from that era included folks like Carroll Dunn, a decorated lieutenant general from the Second World War. He worked full-time on the SICE initiative and later found CII and is the namesake of CII's most prestigious award, the Carroll H. Dunn Award of Excellence. That was the one that John Fish received this morning. One of the academics involved in SICE was Professor Richard Tucker, who went on to lead the effort to found CII and served as its director from 1983 to 1998. And during this era, CII became highly influential internationally. Since its founding 40 years ago, CII has produced a trove of new knowledge and dozens of useful tools, as well as 17 fully validated best practices. CII has launched and accelerated hundreds of successful careers. CII and many of its members among you today have gone on to international renown. Reasons for that success rest with CII's core values, culture, and practices, and the quality of the people involved. And while that renown and success is demonstrated in many ways, including impact on knowledge, practice, and people across the industry, a few particular stories will help us understand the paths that were taken to get there. Those paths were sometimes long. We have been improving project definition, startup practices, and safety for decades. Early CII tools had immediate impact on project performance, and that impact grew over time. Because CII, and that means all of you and us here, continuously improves those tools and extends and adapts them to new sectors like pharma or small projects. And CII keeps getting better at training and implementation. One of those paths that started at the beginning and continues today has been safety. Accidents and deaths have been declining since CII was founded. CII members led this change, and it's a huge accomplishment. Working as a labor and equipment operator in northern Alberta in the late 70s, I experienced the old ways of thinking firsthand. Half a dozen people were killed in trench collapses the summer I worked up there. I almost was as well. Human attrition on big projects was an accepted fact of life. This had to change. The human costs were too high, and the economic costs were becoming immense. A moral imperative emerged that the only acceptable goal was zero accidents, and the problem began to be addressed. Thousands of lives have been saved as a result. If we had continued over the last 4 decades at the same pace as the previous 4 decades, we would have lost over 50,000 more lives in the last 40 years. Those lives were saved as a result of the kind of change that CII and its members have led for decades. Supporting that change were research teams of up to sometimes 24 industry members and typically 1 or 2 academics and their graduate students. The teams were always led by 2 competent and effective industry members, usually an owner and a contractor. To build on what had been learned before, knowledge was archived in the scientific literature, and often one academic served on a sequence of teams. For safety research, Professors Hinsey, Gambates, and Hallowell served this role over time with particular distinction. And there were over a dozen graduate students involved as well. In fact, Gambates and Hallowell started as graduate students on CI research teams and moved on to become distinguished professors and leaders in both their institutions and in their fields of consulting and research. Those teams produced guidelines, checklists, and training materials that members use either directly or adapt to their unique circumstances. The outcome has been lives saved and project performance improved. Another of the paths to success for CII and its members, has been through better project definition. We all know from experience that our ability to influence cost, schedule, safety, quality, and participant satisfaction is greatest at the earliest stages of the project. And the most important part of that earlier work is project definition. A series of CII research teams have produced knowledge and tools to help CII members define their projects better and improve project performance since the early 1990s. A project definition rating index, called PDRI, emerged as one of the key tools in that effort early in the journey. In fact, over the last 30 years, 5 major PDRI tools have been developed and validated. They are applied in the front-end engineering and design stages as teams move through approval gates to project delivery. A leader and source of continuity along this path was Professor Ed Gibson, who served as the academic on most of those teams. Ed has received many awards for this work, as have several of his industry colleagues from CII, like John Fish. There are probably industry and academic colleagues in this room right now who've made major contributions to these tools as well. I hope I don't offend them by not listing all their names right now. We all appreciate those contributions tremendously. The impact of implementing these tools continues to be critical. The difference between low PDRI maturity and high maturity at project commissioning can be huge. The data here illustrate the outcome for a large number of projects that were measured using the Feed Matters tool. And we all know where we want to be in terms of maturity and outcome. The depth and breadth of the CII front-end planning effort over time and its impact have been immense. It's worth taking a moment just to absorb the level of effort involved. It's a lot of money and time and people years and data. Well, startup is another CII success story with a slightly different path. One that was more concentrated within time and one CII research team. These successes often start when an urgent problem has been identified by CII's members. Then a project team is formed to address the problem. And one thing we don't worry about is giving the team a cool name. We try to give it an accurate and precise name. That said, some communication savvy might have helped us occasionally come up with something a little more marketable. So what was the problem that this team was formed to solve? Startup of large, complex industrial facilities was becoming a real issue in the 90s. Expected returns on capital were not being achieved because full capacity was taking years to reach. That's a significant capital projects problem. The CCSU team was formed to address that problem. Close to 20 members with hundreds of years of combined experience joined the team to create a kit of management tools to address the problem. And yes, not all of those tools follow the KISS principle. Sometimes the devil is in the details, and thorough checklists compiled by experienced colleagues can help us do the job right the first time. And this is definitely one of those tools. CII has hundreds of these tools, and you'll probably continue to find gems in CII's knowledge base that will help you do your job better. CII has done a lot of that work themselves to identify the tools and practices that are most well validated. And that work continues today. A CII best practice is a process or method that, when executed effectively, leads to enhanced project performance. CII best practices have been proved through extensive industry use and/or validation. And validation requires a correlation between use of the practice and project performance based on dozens and sometimes hundreds of projects worth of data. For example, and just from my own archives, CII's benchmarking and metrics data on 152 projects from the early 2000s indicated substantially better budget performance for those projects that had high best practice index scores. That meant that they had implemented many of those best practices. Better schedule performance also correlated with CII best practice usage. CII, and I don't have it up here, but CII's Craft Productivity Improvement Program, RT252, in the 2010s, with data from hundreds of projects, showed that better productivity also correlated with best practice implementation. So, it's always something you think about. Can you just take those best practices to the bank and then walk away from CII? That's possible. However, the data indicates that sustained engagement in CII also relates to improved project performance. So cause and effective are always elusive in statistics. However, it's possible, and I think probable, that continuous learning and improvement are supported by membership in a community of like minds, like CII, and in a community of shared values and culture, like CII. So, if we want to stay involved in CII, how does it work? First, CII members identify problems, which become ideas for research teams. Then, research teams with industry and academic members are formed to solve those problems. Academics bring research skills, curious minds, and ideally some humility to the table. And our industry members bring experience, knowledge, judgment, and data to the table. The research emphasizes impacts to capital projects and ease of implementation. Rigor is maintained by focusing scope on biggest bang for the buck, understanding the context of the problem, avoiding bias and unbalanced sample data sets, and avoiding sweeping overstatements after analyzing the data. The research plan and meeting preparations are always respectful of research teams' members' time and concern for confidentiality. We try to use industry standard terminology rather than academic gobbledygook. And in the end, we try to envision research building blocks for subsequent research. If we do all this right, the outcomes are shared new knowledge and validated knowledge, professional development, potential for improved capital projects performance, and new friends. So we've been doing it right, mostly, but what about the future of CII research? I've also been asked to share some of my thoughts on some of the big problems of the future, problems we can work on together through CII. Well, one thing we know from experience is that the world keeps changing, and capital projects keep changing their nature as a result. So we'll need to continue to work on formalizing and validating emerging and promising best practices, or project practices. They're not best practices until they've been properly validated through research. I think we need to face the elephant in the room too. Construction productivity across the industry as a whole has been relatively flat for decades. Not for CII companies who implement best practices on projects like advanced work packaging, but for the industry as a whole. Maybe it's not our fault. Maybe it's due to too much regulation or entrenched interests. But whatever its cause, we need to stay on this issue. One solution might be prefabrication, modularization, and industrialized construction. They're experiencing astonishing compound annual growth rates. We probably need to figure out how to best navigate the transition to a more industrialized construction industry. I think opportunities for step change transformations can be addressed as well. Improving craft workers' health will extend their earning years and expand the labor pool. We haven't spent enough time on health. Figuring out where AI may help us and where it may hurt us is critical. Mixed reality has unrecognized potential, in my opinion, and human robotic systems and decarbonization are probably in our future as well. In particular, the future of safety research likely involves figuring out how to assess risk better, monitoring controls, finding efficiencies, and addressing the challenges of always a new workforce, right? And the future of health may be to figure out how to keep workers earning until they're 65 instead of being forced to retire when they're 55 because their bodies are pretty much done. We need these people. And the solutions may not be cheap. This is me wearing a $10,000 exoskeleton, handling a concrete block like it's a box of tissue papers. That's how I felt. I might have exaggerated a little bit, but I've done masonry without one. I love masonry, actually. And I can tell you it's a lot easier with this exoskeleton. It is amazing. So it reduces fatigue substantially. What about AI? I've worked on AI, you can figure out how old I am, for about 40 years, all the way back to Minsky in the early 80s. And I have a very love-hate relationship with it. It's a resource and data hog. However, it's astonishingly powerful for some tasks, like tracking resources on a project, summarizing large documents, editing our writing, annotating images, it's incredible, and even crafting professional prose. It's turning out to be equally powerful for finding objects in 3D scans of scenes, and general objects, classes, and specific objects. That means we might be able to scan a project someday and moments later get assessments of value earned, schedule deviations, safety problems, and more. And you saw this morning that there are startups offering versions of these services already. Their performance will continue to improve rapidly in the next few years. But there's lots of challenges with AI, especially in construction. Data sets required to train AI are hard to find or generate for construction domain tasks. And they may never achieve adequate levels of accuracy for the task, so they may never be fit for purpose, depending on the application. How will we explain the actions that we took that AI recommended? Who will take responsibility for those AI recommended actions? And frankly, AI doesn't handle exceptions well at all. So will it take more work to handle those exceptions than the work that AI is saving us, or supposedly saving us? I don't know. I think we need to do some research on this. I think VR may be a useful tool. It has some potential for specialized tasks like planning. In this case, planning for disassembly and extraction of operating equipment. For demonstration purposes, I think I have to hit this again, that's right. For demonstration purposes, we created a simulation of a small room with mechanical equipment with the goal of experimenting with disassembly and extraction tasks. In this short video segment, we've already removed some of the smaller parts. And think of this as conceptual. This is research, okay. And we're trying to remove a big piece that does not fit through the door. So the planner decides to cut it into pieces, ends up cutting it into 3 pieces to get it through the door. Imagine, though, downloading this final plan, once you figured it all out, as a set of conventional lift plans, or a set of actions that could be executed by autonomous robots. And it turns out that's what we're working on now. Maybe a little less imaginative, but definitely very useful, are some simple improvements we could make today by creating situations where humans and machines could work together to improve productivity and health at the same time. On the left, the masons lifting and placing blocks in the conventional way. Picking up these blocks from the floor and putting them on the 6th course is exhausting. By the time you're through a shift, you're dead. With the self-leveling pallet, we demonstrated that the mason can always be lifting from waist height, and this improves productivity and levels of fatigue substantially. Just a quick demo here. Just a simple self-leveling pallet. So for a sense of the future of this kind of idea, I borrowed from Professors Manassa and Kamat from the University of Michigan. They're working on a new master-apprentice model based on human robotic systems. It's work funded by the National Science Foundation. This is the sort of thing that many of us academics work on outside of CII hours. Lots of really interesting, crazy stuff, but someday it might be really useful. We also work on things like decarbonization, construction junction. One of my favorite places here in Pittsburgh may be a bit off the grid, but it's places like this that give us hints of where our future may lay. For example, WSP in Toronto is working on reusing structural steel in new construction. The blue shows the base case embodied carbon emissions. And the green shows potential results with the beams replaced by reused sections for these 5 different projects. They've worked out that actual cost may end up being about the same based on their experience with the Capital Block in Ottawa. And we will have made real progress towards decarbonization if we can make these sorts of substitutions. So it's all very cool, but back to CII. How do we maintain the success? I think that as an academic, that we need to keep dreaming up of different ways of doing things, but we also need to stay rooted in real-world problems. We need to get on projects and get our boots and our hands dirty. And our industry partners can help keep it real for us and for the many hundreds of CI research team graduate students who end up working for you, and for the profs who end up educating many hundreds of thousands of undergraduate students who end up working for you. So please help us stay focused on your problems. And all of us need to recognize a duty to change and improve our industry and contribute to society. We need to commit to moving forward by working together and honor the past. And if we do all those things, we can continue to say that CII provides you with a powerful opportunity to affect positive change in your career and the industry. And what makes that opportunity powerful and valuable is its unique partnership between industry and academia. So I know I'm between you all and lunch, so thank you all for your patience. I'm looking forward to a little bit of discussion about these ideas. And before we break, I want to acknowledge that there were many colleagues who contributed to this presentation, and thank you all. Thank you all in the audience here for listening today.
Thank you, Dr. Haas. Excellent overview of the history of collaboration and partnership we have with CII. I will say that our RT302 interface management for me was probably a highlight of my career, which is getting on near 35 years, but it kind of opened my mind to the industry, the oil and gas industry. I wasn't so focused on just the power industry at that point, so I would think it was a game changer for me to be a part of that.
Oh, very cool, yeah.
Thank you. Sorry for monopolizing the question period with me. Where are we here? How can we sustain this successful trajectory of outcomes as well as partnership between industry and academia?
Wow. Let me think for a minute. Well, a big part of it, I think, is we get constant renewal of membership and members. As I recall, it can be sometimes 70% of the people in this room have never been to a CII meeting before. And so we have to, I think, do some knowledge management and share some of the values and the culture and what we've learned over the years, and that just has to be a part of every meeting. I think that you contributing to the membership with your dues, but also with having your people as part of teams is a huge contribution both to their careers and your experience, could be a more common experience. And just maintain that culture and that community of CII, the new knowledge being generated all the time, validated and implemented. It's really improving the industry, and it's just continuing to just invest in new people all the time.
I like that. I like it is research, and we're usually dealing in hard facts and data, but in my mind, it's a lot about the people and pushing them up to the next level. So great point. Just a second here. How can members more easily filter through the old research studies? It's incredibly difficult to determine which ones are applicable and valuable the way things are set up now. And there is a lot of information in there. Yeah,
that's a really good question. There are new tools at CII that's implemented for searching the knowledge base, and that's helping. I think maybe if you focus on the best practices and branch out from there, so see what, in more recent studies, what research teams they referenced, and then maybe it's good to have a few experienced people around that you can access as a resource who can help you navigate through that knowledge base. That's really valuable. So there are some people who have been involved in CII for decades, and they're just really valuable. Maybe there could be some workshops at the next meeting where everybody navigates, or those knowledgeable people answer questions and help you navigate through the database. Maybe I'm just coming up with ideas, but yeah, I should stop there.
That's right. And actually, every time I read a question, Dr. Haas was covering it in his presentation, so some of this is covered already. But what future research directions might be explored, and how might emerging technologies like AI affect these efforts? Yeah, that's a really good question. I think one of the things I identified is processes and practices. They keep emerging, and we keep needing to formalize them because they're really something that you develop, and then the CI research process is the formalization of those and the validation and the turning into a tool that you can turn around and use. So I think that's still always going to be the core of CII in terms of research. And then as far as technology, I think we could get way over focused on AI, and it's part of my own research program. It's going to be super powerful. I think we're kind of at that part of one of those cycles where it's way overrated right now in terms of its actual contribution to productivity and project performance. It's going to just save a lot of man hours, but we're going to always be having to check on it. I think materials are not recognized very often as a real potential source of innovation. I don't know how CI can fund materials research, but it should stay aware of the materials stuff. I saw a wonderful example today of, old school innovation with the Victaulic pipe there, just a giant pipe. I thought that was really cool because it has real value. Victaulic doesn't pay me. Sorry. But it was very cool. So I think that, technology, I think actually mixed reality, I think is going to have a lot of value for things like planning and sharing and visualizing and team collaboration. So all the stuff I shared, I think is going to be useful. This is an interesting question. As part of the research process, why have we transitioned from, let me reword this. Are we looking at transitioning from survey-based data to like real project data? In other words, just people filling in surveys to having actual real data out of these systems that we're all developing for our research?
Well, that is a really good question. And on that team that you were on, we got real project data for 50 mega projects, right? Mm-hmm. We dug deep. It took probably a day per project. So it's hard work to get the real data. The survey data is easier. And CII has gone down that road many times over the years. But it takes a lot of your money to fund a research team with enough resources and then your own time of your own people in your company to dig up that data. So it's a big commitment, and it is absolutely worth the effort, because otherwise you've just got opinions of surveys of opinions, which I agree are of limited use. So I do think that just, if you can invest that money, I know it's a collaborative effort, but that's what's beautiful about CII, then you can get real data on real projects and get really, really useful results. So,
thank you. Just a comment came in here around the database, and I won't say a lot of material, but CII knowledge base will improve as part of RT 398. Someone threw in there, so thank you for that.
Cool.
Glad to see Get Your Boots Dirty as a method for academics to support the industry, or wear exoskeletons, similar thing. Do you have any examples of academics going to the field to understand project execution?
Oh, yeah. In the productivity study, we went out and did activity analysis on projects. So it's a good experience. We learn stuff while we're also trying to get data and help a project. And most of the activity analysis is used to improve tool time or direct work rate. But yeah, lots of academics are out on projects to observe and to get data. I do a lot of craft training, and I love to try the crafts, and so that kind of, I think you got to do masonry to understand it, at least a little bit. So I think, we got to get our hands dirty. We got to do the work. We're going to be crappy at it because we're academics, but we got to do it to have a feel for it. We got to be out on projects, getting data, out on the site. It's super, super important, and it really helps us when we're in the classroom too.
Yes, pilot projects are always handy, and getting that team out in the field to see these pilots makes a big difference, because we get real data, we get people engaged, and that the project wins, and the CII wins, and the industry wins, which is maybe somewhat of this comment here. We need more research that creates white papers, and I'm assuming that's pilot-type papers on pilot projects that truly validate research through deployment. Hopefully I captured that correctly.
Yeah, there's the NASA TRL thing, technology readiness level. I guess you can kind of also apply that sometimes to processes, but it is a continuum, and CI's been pretty good at over the years, really good at, and maybe it just hasn't been shared here, but over the years, CI's done a lot of good research in deploying tools and studying their usefulness in case studies. So it has done that, but it, again, takes resources. So, yeah.
And here's an interesting one. Does the CII, is the CII considered as a PMO or consultant entity in the examples that we just saw?
Sorry, I'm trying to think that one through. Well, both. Sorry, that's my short answer.
And I would say the view of CII, and we've discussed this before, it's our very affordable R&D office that gathers everyone together. So really, CII is OPG's research and development group, which is a pretty good bargain for the price of membership.
Yeah, Jamie, I hope I got that right. Okay.
And that's about it.
Thanks. Real happy to chat and meet everybody, or as many people as possible. Afterwards. Thanks very much.